Hi. So in this section, 9.4, we're going to take now and dip our feet into the pool now and discuss rare events and what we mean when something is unusual. I know we've used that in our class, like, God, this seems a little unusual in our probability chapter. Winning the lottery, we're like, well, it's highly unusual. And we talked about luck. So we're going to talk about that in a more like scientific statistical sense now because it is actually something for something unusual to happen is actually related in a mathematical way. And we get to kind of touch base on that today. And also talk about how sampling is so important and conclusions and how we make the conclusion whether an hypothesis is valid or not. So we have a few things to discuss. So when we talk about hypothesis testing, there are a few steps we talk about, right? The first thing is actually to just make a statement, right? Just say, you know what? I think the number of minutes people spend on a cell phone talking rather than texting has increased since 1985, right? That's a claim, right? I made a statement. Then what researchers do is go out and start collecting evidence, and that may be making their own research and sampling distributions and sample statistics, or going out and finding what exists already in research. So collecting the evidence is that second part. And then the third part was to organize that evidence, test it, and see if there's any validity to the statement made, right? To analyze the data. Okay, so of course I love the lottery, as you know. So in the California lottery, the odds of winning first prize super lotto jackpot are 1 in 41,416,353. And the odds of winning the mega millions is even more unusual, right? 1 in 302,575,350. Why would we consider winning either of these events unusual? Well, recall back when we did chapter 3, we said an event is unusual because oh because the probability was so low. All right, and I think even some of our probabilities were less than 1%. Well, let's see. Let's do the super lotto. So if we did the super lotto, right, it would be 1 in 41,416,353. So if I went ahead and put this into the calculator, I wonder what the calculator would give me, right? So 1 divided into 41,416,353. And so it gives us this number of 2 point blah 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 with e negative 8. That means that there are 7 zeros in front of the 2 and then the 2. So this would be 0.000000002, right? Or point, and I can move the decimal over and have 5 zeros, 1, 2, 3, 4, 5, 2%. So this is a lot less than 1%, right? And so we usually say an event is unusual when the probability is so low. And so then the question comes up is how low? Like what's the barrier? Is it 1%? And we say that in hypothesis testing, we actually say an event is unusual is when the probability is less than 5%. right? And that just comes from what we're going to discuss in just a few moments. And so when we make an assumption and the sample statistics displays that it would be unusual for the assumption to be likely, then we have to say, okay, well, if it's unusual for this event to occur, most likely it's not going to occur. If it's unusual for someone to win the mega lottery, you're probably not going to win. And so that's when luck comes in, right? When someone wins, we're like, oh man, you're so lucky, because it kind of is. I mean, because the odds are so against you that um, when you win something, I get excited when I have a scratcher and I win something, right? So just kind of think of that 5% barrier is the unusual.